Okay, so this is Thomas, and I will do a quick demonstration of the Fizz-Buzz kata that we are including in our prep course materials, the CraftAcademy Bootcamp Prep. Let's jump straight to it and share my screen, and we can start coding a little bit. So what we will do today is that we will solve the Fizz-Buzz challenge, do it a little bit in a bit of a test-driven development way. It's an introduction to test-driven development to our students. So let's have a look. And one of the first things I'm going to do is just going to show you the course materials for that, and they are located at class at CraftAcademy. And let me just sign into that system. That's the October one, so that's not the right one. Coding as a craft, bootcamp prep, bootcamp June, August. Here we are, and we go to the course, and I'm just going to view this as a student, and we go over to test-driven development and the Fizz-Buzz challenge. So. So the concept of test-driven development is very simple, I would say, but also very complex, especially for new students. The idea of solving a problem with software is of course easy to understand. What is harder to understand is the process of writing scripts that actually test or assert that the software that we are writing is doing the right thing, and doing it in the process of writing or implementing your solution with code. So what we do in test-driven development, or TDD as we often abbreviate it, is to write a test first, see it fail, implement a solution that makes the test pass, and then move on to the next feature. There's also another step called refactoring in that cycle, but we will cover that later on a little bit. So what we do is that we use our tests as a blueprint or as a path forward that shows us what it is we need to implement. And in this little challenge, we will deal with a children's game called Fizz-Buzz. The game is fairly simple. It teaches kids about division, and what happens is that players take turns counting up from 1, 2, 3, 4, 5, and replacing any number that is divisible by 3 with the word fizz, which means that 3, 6, 9, 12, etc., is replaced with the word fizz. If there's a number that is divisible by 5, that number is replaced with the word buzz, and a number that is divisible by both 3 and 5, which basically 15, for instance, is replaced with Fizz-Buzz. And in real life, this is a very boring game, but it gets fairly complicated rather fast if you go up to higher numbers. But we're not going to play the game as human beings, but we will write a piece of software that plays the game, basically. Okay, so the objective here is to write a little program that takes a number or a collection of numbers stored in an array, for instance, and returns the number or Fizz-Buzz depending on what number has been passed into the method, given certain conditions are fulfilled. So again, we return fizz if the number is divisible by 3. We return buzz if the number is divisible by 5. Fizz-Buzz if the number is divisible by 15. And of course, we return the same number if no other requirement is fulfilled. So if it's not divisible by 3, 5, or 15, we just return the number. Which means that if we have a look at the sample output, we return 1 as 1, 2 as 2, 3 as fizz, 4 as 4, buzz, fizz, 7, 8, etc., etc. You get the general idea, I hope. Yeah. So we want to introduce you guys to something that we call user stories. and we will be talking about user stories much more further down the road in this bootcamp or in this class. But today we can just focus on these 4 stories that states that as a programmer, so that the game can be played according to the rules, I want a normal number to return that number, you know, which of course could be, you could debate what is a normal number, but we will settle for that story at the moment. The next one says that as a programmer, so that the game can be played according to the rules, I want a number divisible by 3 to return Fizz. Okay, so that's an objective for the software that we will be building. And also I want a number divisible by 5 to return Buzz, and I want a number divisible by 15 to return Fizz-Buzz. Fair enough. So, we, as I said before, we will be using test-driven development to do this. This means that in general terms, we will start with writing a test for the application. We want to see it fail, write the solution and implementation, and watch the test pass. Okay, and the testing framework, the framework that we will be using to test our application is called RSpec, and we will be using Ruby as a programming language to implement a solution for this challenge. So let me just get a little busy here with preparing the stage for my development at the moment. So what we want to do, we want to create a folder where we'll be placing our project, and I'm just going to create a folder called Fizz-Buzz and cd into that folder. What I want to do after that is to create a file that is called gem file, and add a library called RSpec as a dependency. So what I will do now is I'm going to create a file called gem file, and I use a capital G for this and no suffix. And I'm going to open this file in my text editor, and I'm using Atom for that. Hopefully you guys are too. Atom is a very great tool, so feel free to download it, use it. I think it was a requirement in oh, that's the wrong window. Sorry about that. Here's the one that I want. There we go. Sorry. So we have the gem file here, and so the gem file is a file where we store information about what libraries we are using to help us in our development. And the first thing we want to do here is to tell our system where to get the source of the gems that we want to pull down. So gems is so libraries are called gems in the Ruby world, basically. So we're gonna fetch them from rubygems.org, and we're gonna add one single dependency to start with, and that is RSpec. So we just type that in and go over to our terminal window. And before we can actually do something with that gem file, we want to make sure that we have a piece of software called Bundler installed on our system. So we do gem install Bundler like this and let it run. See that execute. So I'm getting some warnings and errors on my system. I do not know why, to be honest, because I haven't researched it, but it did install Bundler version 1.12.5 on my system, so that's perfectly fine. This means that I can do, if I've saved this, yes I have, so I can do bundle install. So bundle install is a command that we use to install the dependencies that we have saved in our gem file. And this will reach out to rubygems.org and install a series of libraries. So as you see, even if I only specified RSpec as a dependency, it actually installs 1, 2, 3, 4, 5, 6, 7 different libraries, because each library is dependent on other libraries. You don't have to think about that for the moment, but I want you to know that this is what's happening. And also, if you go to your editor again, you see that there's a new file created in your file structure that is called gemfile.lock, and this is an auto-generated file that lists all the dependencies. You don't have to modify this file ever. This file is used by Bundler just to keep track on what libraries have been pulled into the project. Okay, this is about as much setup we have to do in terms of adding a testing framework. What we want to do now is to initialize RSpec to be able to start to use it. So what I'm going to do is type in a command that says RSpec init, and this command will create a folder called spec, a file called spechelper.rb, and another file that is a hidden file that called rspec.rspec. And the hidden files, hidden files always has a dot in front of its name. So let's go and have a look at that. We see here in our editor that we have this new folder. Inside of that folder, we have the spechelper.rb, and we have the rspec file here. If we open this one up, I would like to change the default behavior of RSpec to be a little more verbose, to give me more information in my terminal when I run my tests. So what I'm going to do, I'm going to add format documentation to it. Yeah, that's it. Which means that when I run RSpec now with the RSpec command, I will just get that no examples were found, and that it finished in like 2 milliseconds or something. This is just a sanity check just to see if RSpec is correctly configured in my system. We have no tests written for this application yet, but I just wanted to make sure that everything is working correctly. So let's go back to our documentation and see what the next step is, basically. Okay, so we will start now by writing a test for our game. So the first thing we want to do now is to create a test file. And it's very important that we understand that all our tests will be placed and located in the folder that is called spec. So what we will do now is just to go ahead and create a file that is named Fizz-Buzz spec.rb. So let's go back to the terminal and type touch spec and Fizz-Buzz spec.rb like this. And now when we go back to our terminal, we see that we have that new file there. So once we've done that, we want to open up that file, and we want to add something. First, we want to require a file called Fizz-Buzz that will reside in our lib folder, and we want to add something that we refer to as a describe block. We want to describe the functionality of this file in this method. So this is what I'm going to do now. We're requiring the Fizz-Buzz file, and we add a simple describe block. And now the funny thing here is, we will talk more about the describe block in a second. But an interesting thing here is not that if I run RSpec now, I will get some errors. And it's very healthy for you guys to see those errors. And they could be a little bit intimidating at first, because RSpec returns a lot of text back to us, and as a newbie, you can be a little confused by all this. But most of the time, not always, but most of the time, the relevant information that you are looking for is in the first two lines of this output, this error output that you'll see. And here we can see that in our Fizz-Buzz spec file, we are trying to require a file that cannot be loaded because it doesn't exist. Okay, so there's a load error, and the rest of this output is irrelevant for us at the moment. Okay, and of course we cannot load a file that doesn't exist, right? So that's the first thing that we want to fix. So I'm going to create a folder that is called lib, because that's what we point to. We point to a lib folder. That folder doesn't exist. And then I'm going to touch a new file called Fizz-Buzz.rb in that particular folder, like that. And now we're going to run rspec again, just to see that the error message is gone. Okay. And this might seem trivial to you. Of course, I knew that this would show up, and so why does he even bother? But the most important thing, there's a lot of most important things, of course, but one of the important things that you have to think about while developing in a test-driven way is to keep on running your tests and keep on looking at the error messages, because the test-driven development is a series of failures until you actually make the test pass, right? So, and each time you change the error message, it means that you have taken a step forward. And at this point, we actually took a little step forward. There was a load error, now there isn't a load error, which basically means that we made progress, and progress is good. Okay, moving on. Let's have a look at what we've written in the documentation. Yes, we described this process in the course documentation as well, that you can access later on. But let me be clear on one thing, and this is very, very important. So our tests, that we refer to as specs, which is a lingo thing that we have to pick up. Sometimes we say test, sometimes we say specs, and it basically means the same thing. They are all placed in the spec folder. Okay, our implementation code or production code or software, whatever we want to call it, is placed, in this case, in a lib folder. Okay, so we place our software in the lib folder and our tests in the spec folder. And if you think about it, we want to make a distinction here between the test files and the implementation files. So that's why we have a Fizz-Buzz.rb file where we'll be placing our code. And we have a very, very similar file with the addition of spec in the spec folder. So we know that this test file is testing the Fizz-Buzz.rb file, basically. So we try to keep that. I could call this whatever I want. I set this name by myself, but it's a smart way of doing this. You want to name your files very similar to the ones that are actually testing, basically. And of course, you want to give a descriptive name to the implementation file, so you actually know what that file does as well. You know, we're dealing with the Fizz-Buzz game, so we call it Fizz-Buzz.rb, basically. All right. And all your settings, like the gem file, etc. In this project, we won't have many setting files, but they are usually placed in the main project folder, at least in pure Ruby projects. All right. Okay. So let's write some tests. Okay. So inside of our Fizz-Buzz spec file, in my describe block, I want to write my first test, basically. So for that, we create something that we call it blocks. That is the where our expectation is being placed. So that's you can refer to this as a test, basically. So we're going to say that it returns 1 if passed in 1. And this means that our software or our method, if you give it the number 1, it should return 1, because that's the name of the game, right? 1 is not divisible by 3, nor by 5, nor by 15. So that's when, so let's write an assertion. And for assertions, we use a keyword called expect. So we expect something to happen. And at this point, we don't have any code yet, but out of experience, or I've done this before, and I know that what we might do is add a method to our game that is called Fizz-Buzz. We can call this method whatever we want, but let's call it Fizz-Buzz, and we pass in a number 1 to this method, and if that happens, then that should equal 1, basically. So if you pass in 1 to the Fizz-Buzz method, then you should get back 1 from the system. All right. And now the fun begins. Let's have a look what happens. So we run artspec again and brace for impact, because this will fail, of course. And so what it says here, that we have a failure on that test, and it says that there's something that is called no method error. Okay, and of course there is no method error because we don't have a method called Fizz-Buzz. We haven't written anything. Okay, so undefined method Fizz-Buzz for whatever, basically. Let's try to fix that, basically. So let's go back to our implementation, and if we have a quick look at our documentation, we get the same error because we don't have that method. So let's create that method. So we go to our implementation file and we define a method called Fizz-Buzz. Right? And we just call it end. We just create a very simple empty method to start with. Okay? And the reason I'm doing this now is because I want you to see that we are changing the error message. So if we run artspec again, we are not getting the same message as we did before with a no method error, but we say that there's a wrong number of arguments. It expected 1 argument. It was passed in 1 argument, but it didn't expect any arguments, because if you have a look here, we're not telling the method to accept anything. So let's just tell it that whatever value we are passing into this method will be stored in a variable called number, and run the let me just do a quick change here because I'm not really happy with the red color on the error messages. So let's see here. Tanyan Fenster. Where do I set that? Colors, fonts. Where do I set that? Block. I change this something lighter. Still red, but lighter red. Yeah, there you go. Yeah, let's go with some purple. So it actually shows on the display. Yeah, let's do this. Okay, so now you see it better, probably. Okay, thank you. So what happens now when we, let's see if I save it properly. Yes, I saved. So now we will change the message again. And so it doesn't complain about the number of arguments, but it expected 1. If you see it expected 1, but it got nothing because the method isn't returning anything, right? So let's just make this test pass. So we say return number, right? And this will pass now for us. Boom. All right, green is good. You see that my editor actually removed the return keyword, because in Ruby, we don't have to use that keyword. You can use it if you want, but Atom is smart enough that it shortens my syntax a little bit. The only thing this method does at the moment is to return that number. We are passing in 1 and we're getting 1 back, which is exactly what we wrote in the test, right? Of course, it doesn't mean that we are done because we haven't implemented any of the rules yet, but at least we know that if you pass in 1, you will get 1 back. All right. So let's have a look in our documentation again. This is exactly what we implemented. Let's write the next test that will make things a little more complicated. Okay. So we go back to our Fizz-Buzz spec and we create a new if block saying that we want to return Fizz if number is divisible by 3. All right. So we know that this one is passing, so that's a no-brainer. But expect Fizz-Buzz, and we're passing 3 to that method, and that should equal Fizz. All right. Let's save this and run our tests. And the first scenario will pass. It will still return 1, but the second one will fail, complaining that it expected Fizz, but it got back 3. Because that's what we do. We only return the number that is being passed in, right? So what we could do now, just to make things interesting, we could say if number equals 3, right? Then return Fizz, right? Else return number and end, right? Does that make sense? So if the number is 3, then we return Fizz, and else we return number. It will make the test pass. I'm deviating a little bit from the documentation at the moment, but you will understand why. Is this a complete solution? Of course not, right? So, because if we would, what we would do now, is, according to the rules, the Fizz should be returned also when we pass in 6, right? So let's run that. And that will fail for us. Well, I'm sorry, I didn't say it. So. Yes. So because the implementation is not correct at the moment. So what we can do now, we have a solution for that, of course. So let's say that we want our implementation to have some methods that actually checks the number, whatever number that is passed into the Fizz-Buzz method, and we want to check whether it's divisible by 3, 5, or 15, right? So now at this point we have to decide for some naming standards. Okay, and again, we can name our methods whatever we want, but there are some common naming standards that we can follow, and there is a document about that in our course documentation. I will link to it in the description of this video. But how at this point, let's settle. How about creating 3 methods and name it divisible by 3 with a question mark, because it will return a true or false. That's the only thing. We just want to have is it divisible by 3? Yes or no, true or false. And by 5 and by 15, right? So let's just grab this content here, make it a little easier for us, and go back to our editor and just paste it in like this and say def, and of course an end here, and here, and here, right? Now we have 3 methods. And so let's see, now we need to, of course, fill those methods with some algorithms. It's not some way to knowing whether this is divisible by 3 or not. So this is something that we need to create. And also, in my example here for now, I used an if and else statement. There is a different way to do that. What we can do is to use a case statement instead, which is just a different kind of doing a very similar thing. So let's just pass that in. And number, so we have to pass in an argument to each of these methods. So we have to allow it to take the argument. Like this. Okay. So what we are saying here now, we're using a case statement, and when divisible by 3, then return Fizz, else we return a number. All right. So the problem here is now that we don't have any way of knowing that. This will probably return nil for us. So we have to fill this this divisible by 3 method with a way of knowing that. And one way of doing that is to use this modulus operator, which is symbolized by this percentage sign. Let me just paste this into my implementation here, and I will talk you through this. So what this does is that you take the number, you divide it by 3 in this case, and the remainder of after the division is 0, which means that there is nothing after the comma. You know, it is not a 1.5 or something. That is the whole number. So if there is nothing after the comma, then this returns true, basically. So this means that if this is a 6, so 6 divided by 3 is 2. There is no decimals, right? If you would have taken 7 divided by 3, you would have decimals, and then this would be evaluated to false, basically. Okay, so now we have made some heavy changes. We changed the way of we changed the way we deal with how we treat a number in the Fizz-Buzz method. We're using the case method instead of if and else. And we also added those methods of divisible by 3, 5, and 15. But let's just settle for this right now and run our specs and see what we end up with. And now everything is passing for us. So both 6 and 3 is okay, basically. So return Fizz divided by 3 is, so let's just change that a little bit. If number is 3 and if number is 6, right? That will be more appropriate message. So you want to think a little bit about how you know what you say in those if blocks, because that is what you see on the in the terminal output, and you don't want that to be too vague, or it should be descriptive enough, basically. So now it returns 1 if passed if passed in 1. So let's change that again. If number is passed in number is 1. Oh shit. Let's just add that. If, yeah, something like this. Makes sense, right? Good. Okay, so now we want to do, we want to copy this and want to say that it returns buzz, right? If buzz main number is 5, for instance, right? We just change this because 5 should return buzz. And we run this. Oh, sorry. Wait a minute. There we are. We run this. And we get an error. No, we don't get an error because Thomas forgot to save. Sorry about that. Let's try again. Yes. it expected buzz, but it got 5, right? Why? Well, pretty simple. We haven't implemented any way of knowing if this number is divisible by 5. And that's very simple. We just change this. Is it divisible by 5? Like this. And we add another line, another condition here, right? And say when divisible by 5, then buzz, right? Good stuff. If it's not divisible by 3, then move on. The execution moves on to the next line. If it's divisible by 5, then it returns buzz and stops that method. You know. Okay, let's save and run RSpec, and we're moving forward. Good stuff. Okay, so this means that just as a sanity check, what we can do is do 10, right? Just to make sure that it doesn't, you know, it doesn't only work for 5, but it actually works for 10 as well. So let's do this. And we are A-okay. Good stuff. All right, moving on. Let's write another one and say it returns Fizz-Buzz if passing number is 15. Okay, so we pass in 15 and we expect it to say Fizz-Buzz. All right, so we expect Fizz-Buzz 15 to equal Fizz-Buzz. So we're making an assertion, as with everything else. And we save that, and of course we're going to get an error because that is not implemented yet. You get the hang of it now. It expected Fizz-Buzz, but it got Fizz. And that's interesting, isn't it? Because 15 is divisible by both 3 and 5, right? Okay, so one would be tempted, and I would just make this error for the moment, because, you know, we're implementing stuff, we're adding things, right? So let's add this here now, all right? And 15, right? And then, of course, we just grab this and add that assertion, that algorithm to this method. So we have 3, 5, and 15. Oh, sorry. Good catch. Thank you. That's why we should par program. So we catch those errors. And we save this and we run, and doesn't work. Now that's interesting. It should work, one would think. So without submitting you to this torture, I will just do this. What? Oh, sorry. And move it up here. And this will pass. And now we can ask ourselves a question, why is that?
Because there is no conflict.
There is no conflict, exactly. The first thing we want to do now is to, well, sorry. That was my grand finale here, but I just messed it up. I'm sorry. Yeah, this should pass. The thing is that since 15 is divisible by both 3 and 5, the first line, if we had this on top, this will evaluate to true. You know, so we have to check for 15 first before we check for 3 and 5. You know, there is no conflict between 3 and 5 usually, apart from those few, like, you know, 15, 30, 45, etc., etc. You know, so that's why we need to have that on top, basically. Okay, and you know, this is it. This pretty much solves the whole pattern. We have made a small little game that does fulfills all the requirements that are in the rules. And what we could do now is we can jump into IRB, and we can do, what can we do? We can load lib Fizz-Buzz.rb like this, and what do we want to do here? 100 times. No, how do I want to do this? I have that here someplace, don't I? I keep forgetting that. Yeah, 100 times output Fizz-Buzz. Yes, okay. So do 100 times, and then create a block, and yes, sorry. Oh gosh, I'm tired today. So let's create an array first, and then 100 times create save each number in a variable called number, and I'll push that number into the output array, but using the Fizz-Buzz method and pass in that number. So first time it's a 1, then it's a 2, 3, 4, 5, because we do it 100 times, so it's an iteration. And we close the block. So these curly brackets in this case are equivalent to the do end. The first curly bracket is the do, and the second one is the end. In that way, we can pass in a block in one line. So 100 times, perform this operation, store a number in the variable named n, and push that into the Fizz-Buzz to the output array once it's been processed by the Fizz-Buzz method. And so let's do that. And now we say output like this, and we see that, oh, it took the 0 first, because I should add, it always starts with 0, so it was a mistake on my side. But 1 is 1, 2 is 2, 3 is Fizz, 4, blah, 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 and etc., up to 100. So we solved it. That's it. Okay, so let's just go back to the refactoring part, and we talk about it in our course materials as well. We had that someplace. Where is that? Or did we? Well, perhaps we didn't bring that up, or did we? Yes. So here, so the challenge is solved. We've already done everything, but there is a potential improvement that we could do. And before I talk about this, let's go back to our implementation. So we might want to do this or not. It depends a little bit, and of course everything is opinionated. So some other developers could have a problem with what I'm going to say now. But we're doing a very similar calculation in each of these three methods. And since we want to kind of be dry, don't repeat ourselves, we don't want to have a repetitive code over and over again. So one way to do this, to achieve this, is to extract this calculation to a separate method and make it a little more abstract, basically. So what I did this is, here in my documentation, we created a method called has0reminder. I would actually add a question mark to that. And then I would just, in this methods, I would say has zero, zero reminder, question mark, and then pass in 2 arguments. And the first one is number that we are passing in, and the second one is 3, because that's what we want to divide it by, right? So we are passing in 2 arguments here, and we take the number and use the modulus operator on it with the divider, and that should equals to 0, right? So we can call that method from any method here, and it kind of, in a way, makes it a little less repetitive, but it's still a little repetitive. So that's why I'm not really sure whether this is a good refactoring or not. But I just wanted to show you that we can still have the tests passing for us after we've made rather significant changes to the code. And that is what the refactoring stage is all about. So we don't want to change the behavior of the software. We just want to change the way stuff are being done. So we changed the way we are checking for true or false, but the tests are still passing. So the functionality hasn't changed in any way. All right. Again, I'm not sure whether this is a good refactoring or not. I just wanted to show that it's possible to do, basically. Okay, so another thing, if this was a class, and this is not a class, this is just a setting of, a set of methods in a file, I would definitely mark these methods private, because the only method that is really interesting for us from the outside world as users of this software is this method. The other methods are, I sometimes, refer to them as helper methods. They are only called from within the program. You cannot call them from the outside, So if when we work with classes later on, I would definitely mark them as private, so they cannot be accessed from outside. But, this is basically it. What we just see now is a very simple process of writing some tests and using the tests to drive my process. I start with a very simple method that does basically nothing. It only returned a number, but it made my first test pass, right? So then I add some complexity. I added the test that checked that the number 3 is returning Fizz. It didn't pass, so we made that work. Then we added another test and made that pass. And this is the trick here. The trick is to think about how do I want my software to behave, write a test for it, and implement the bare minimum amount of code to make that pass. And then you add another test that makes it a little more complex, then you add the complexity. You don't overthink things and try to write too much code until you actually need that code. All right? So yeah, that's it. And there is a very detailed walkthrough in the documentation, step by step. This is your first exposure to test-driven development. So just go ahead and follow those steps. There are some small traps here and there that you will face, but the most important thing is that you start to think about certain the workflow, a certain approach, certain attitude to how software is being written, and complete this task, basically. Yeah, so that's about it. Thank you for watching. I'll be posting some links to the course documentation in the description of this recording, and I hope to see you again. Thank you.